Hi guys, welcome to the part 4 of this series. My name is Chidi and today we'll be diving straight into building the model architecture, which is the brain of both our tabular dataset and our image dataset, and we're making use of TensorFlow and Google Colab as our workspace. So let's get started. To define the architecture for the image dataset, we use the convolutional neural network, and this is the sample block of code for convolutional neural network. Why? To define the architecture for the tabular dataset like CSV file or spreadsheet, which are in a table format, we use the dense neural network, and this is a sample block of code for dense neural network, which I'll be explaining to you in a moment. Right now, what you see here is the full architecture of the model. It starts with two convolutional layers for feature extraction, as you can see. The first one, conv2d, then followed by mask pooling layers, which we use to reduce special dimensions. And after the mask pooling layers, you can see this is the first mask pooling layer, the second mask pooling layer. Then the next thing we do is what? To flatten the data, I will pass it through fully connected dense layers for our final classification. As you can see, this is a fully connected dense layer, which is the final stage. Don't worry if this seems a lot for you at once. We'll take it bit by bit, layer by layer, and I will explain each part, what it does and why we use it. This slide explains how to define a basic convolutional neural network using Keras library. In general terms, to define the neural network model, all you have to do is to create an instance of like a sequential model, and you add your layers in the order you want them to be executed. Like as you can see, we did this in the last part of our code. This is our instance which we've called the sequential, and inside the brackets, this is the open bracket and this is the closed bracket. We define what layers inside them. So these layers are defined inside the sequential brackets. The sequential here is already defined model. It's a defined model class in Keras library. It's like an instance. So when you call it, just respond. It already knows, already defined to act in a particular way. So whenever you call it like this, it knows what to do, because it's a class, a model class already defined in Keras library, which you usually use to build neural network layer by layer, especially when the model flow is like mainly from input to like output. This model underscore CNN is a variable. Like a container. It takes whatever has been specified or defined the right side of the code. This takes whatever has been defined right side of the code. So once we've specified this instance sequential and we've defined our layers inside the sequential bracket, layers are like this: conv2d, mask pooling, conv2d mask pooling, flatten, dense, and these are the layers. So once we specify the layers, so everything here at the right side is stored inside this, which we've defined. You can call this anything. It can be named Joshua, you can call it model C, you can call it any other thing. So why do we do this? Why do we store this here? Is because there's a part of the code where we have to call this model underscore CNN. As you can see, the last part, when we wanted to compile it, so we had to use the variable name to call the instance, which will be stored on the right side of the code. So the next thing is for us to learn what's inside this bracket, which is the layer, and how to specify them. These are the layers, like I've said initially, like the conv2d, the mask pooling, the flatten, and the dense layer. Let's break down what this line of code means. This line of code, let's break it down, what it means. As you can see, this line of code. So I replaced each of these inputs with 1. This is the first input, the second input, the third input, and the fourth input. So there are 4 inputs inside. So I replaced it with, let's say, 1, 2, 3, 4. 1 represents the number of filters. So you have to specify the number of filters here. For example, you might set it to like 32. These filters help the model to learn different features from the images like edges, corners, and textures. So if you want the model to learn edges, corners, and textures, we specify that using the number of filters, which is 32. For the second one, It stands for filter size. It can be 3 by 3. This is like saying each filter will scan the images using like a 3 by 3 grid of pixels, like looking through a small windows to find patterns. While this third one refers to the activation function, such as ReLU, TAN, or others. This function introduces non-linearity. It helps the network to learn more complex pattern. As you can see, this is number 3, activation function. We can use ReLU, we can use TAN, or others. Then the fourth one, finally, is for what? Specify the word, the input shape. This is the input shape. And this is really important because it tells the model what kind of image to expect. Like the model is just there, it doesn't know what it's expecting. So when you specify this, it tells the model what kinds of image it will expect. It tells it the width of the image, the height of the image, and the number of color channel of that image. So for instance, a typical RGB image might have something like, you might see in the bracket, you see like, let me show you. You can see this 150, 153. This is the image height, the width, and the number of color channels. So in summary, this is like saying, hey Keras, build me a convolutional layer with what 32 filters. Each you have a 3 by 3 in size, using a function of activation called ReLU, and expects an RGB image or a 3-colored image of size 150 by 150, the height and the width.